Okay, guys, we're moving on to dividing polynomials. And I don't want you to be scared about this. I just want you to take your time. And if you're not familiar with long division or you haven't done it for a while, then I suggest that you start brushing up on it. You would probably, I'm just going to throw a few things here. You would know that, say, 72 divided by 8 is 9. You know your timetables, that's okay. But if we applied the long division, we know that 8 doesn't go into 7, so we'll put a 0. And then obviously it goes into 72 9 times. Now, if we had something like 3 goes into, let's say, 76, okay, we would have 3 goes into 7 twice with 1 remainder. And then you would say 3 goes into 16 5 times with 1 remainder. And then we'll move into decimals, etc. But obviously, we're not going to be working with decimals. With this case, you would say, let's say, what is it, 15 with remainder 1. Now, I want to take it back a little bit further because that's all shorthand. If we had 3 again and 76, the long division process is you would be going, well, 3 times 2 is 6, and then you would subtract, and then you would have 1 remainder. Then you would bring down the 6, and then you will say, well, 3 goes into 15. 3 goes into 16 5 times. 3 times 5 gives you 15. Take away 1. That is your remainder there. Okay. All right. So now, how does this apply to polynomials? We're going to be using the long division process, and I'll do a few examples in this video. And so it might be a long video, but at least we've taken it through step by step. Okay. So let's get a few questions out, shall we? So we'll have something like this: x squared plus 9x plus 20 divided by x plus 5. We have a quadratic equation divided by a linear expression. Okay, and if you could transform that into fraction form like that, that's just the same. But if we're going to be applying long division, then we're going to have the divisor over here, and then we'll have the dividend, the thing that is being divided, on the inside. Okay. Now we know that this is the leading term and this is the leading term. The leading term for the divisor and the leading term of the dividend. What you want to do is divide one by the other. So x squared divided by x is just x. Okay. And I prefer to leave it, put the x on the second term, okay, and you'll start to see all of this come into play when we do a few more examples, okay. So the other way of looking at it is saying, well, x times what gives you x squared? Well, it's just x. Or you could say x squared divided by x is x, okay. Now what we want to do is we want to multiply those two across, okay, we'll multiply it back into the two terms in the divisor. So x times x is x squared, and then x times 5 is 5x, okay. So once we've done that, I'll just take that out. Then we subtract, and I want to put brackets here because the subtraction applies to both terms. So x squared minus x squared is just 0, and then 9x minus 5x is 4x, okay? Now, we can then do the same thing. We drop down the 20, and we're left with 4x plus 20. I'm going to do the same thing. Here's your leading term, and here's your new leading term. So we want to know, well, how many x's fits into 4x, or 4x divided by x is going to give you the same value. That is 4. Okay, so now what we want to do is we want to multiply that 4 across to those two terms. So 4 times x and 4 times 5, that's going to give us 4 times x is 4x, and then 4 times 5 is 20. We'll do the same thing. We want to subtract these two terms from the top. 4x minus 4x is 0, and the same thing with 20 minus 20 is just 0. So there's no remainder. So what we have here is the answer, the quotient. Okay, so what we have is basically x plus 5. No, sorry. So we have x squared plus 9x plus 20 divided by x plus 5 is equal to x plus 4. And the way that you can check things, you can expand the brackets. So we could say that x plus 5 times x plus 4 should expand out to x squared plus 9x plus 20. Okay. Let's move on to another question. So here we have a polynomial with degree 3, being that the leading term has a power of 3, and it's divided by another linear expression. So we've got a cubic function divided by a linear expression, and we'll put that in our long division structure. And we'll do exactly the same thing. Okay, so x cubed divided by x is going to be x squared, and then we're going to multiply that across. So x squared times x is x cubed, and then x squared times 2 is 2x, and we're going to subtract. Okay, so x cubes disappear, and that's what we want. And now that 3x squared times, so 3x squared minus 2x squared is just x squared, and then we can bring down the x. We will do the same thing. So x squared divided by x is just x, and then re-multiplying across. So x times x is x squared, x times 2 is 2x, and we're going to subtract. Okay, so x squared minus x squared is just 0, but x minus 2x is minus x. Okay, so that's why it's really important that you put the brackets to ensure that you have the polarities correct. And then lastly, we're going to move the 9 down. So there's a plus 9, and we're going to be looking at, well, x minus x divided by x, so minus x divided by x is actually negative 1. So we want to put a negative 1 in the end there and multiply it across. So 1 times x, minus 1 times x is minus x, and then minus 1 times 2 is minus 2. And we're going to subtract that. And notice that, again, putting in brackets the importance of the polarities, because a negative times a negative becomes a positive. That makes it 0. Same thing, negative times a negative is a positive. So 9 plus 2 becomes 11. Don't make the mistake that it's 9 minus 2. Yeah, so this is going to be your remainder. So in this case, we have a remainder because we've run out of values here. There's nothing left. So your answer is just going to be your quotient, okay, is going to be x squared plus x minus 1, and then remainder 11. Okay, with this example, we've got an even bigger polynomial with a degree 4. But what's different about this particular question is that, let's just fix this question up, that we don't have, we've got an x to the power 4, we've got a 3x to the power 3, we've got a 2x to the power 2, but we don't have just a regular x. With some previous, so with some other polynomials that we dealt with, we've been looking at the expressions, and each term of x's actually fit in, and then c is your constant. So it reduces by 1 each time. Okay, and in this case, with this question, one of those terms is missing. So what we need to do is we need to still include it in our expression, but write it with a 0. Okay, so we're going to have 0x here because it doesn't exist. And then it's kind of like putting your zeros in your place values. If you had, say, 207, there's no tens here, okay, but you still need to put that value into this expression to make it all align correctly. So we've got x plus 2 on the left here as our divisor. Now that we've included the missing piece and everything is in its correct place value, we can then carry on and do the normal thing. Just because there's 5 terms doesn't mean it's any more complicated, just takes a little bit longer. So x to the power 4 divided by x is just x cubed, and I'm putting it here. And then re-multiply, so x cubed times x is x to the power 4, and then x cubed times 2 is 2x cubed. We subtract, and we'll have 0 minus 3x cubed, take away 2x cubed, because a negative times a positive is a negative, is minus 5x cubed. Then we're going to bring down the 2x squared and do the same thing. So minus 5x cubed divided by x is going to leave us with minus 5x squared. Okay, so if you really need to figure that out or write it to the side, you can just change it as such. Okay, do what you need to do to ensure that you haven't missed anything. So now we re-multiply. This is a negative 5x squared, so don't leave that negative. We have negative 5x cubed here. Multiplied by 2, we get minus 10x squared. And we're going to subtract. We've got 2 negatives, makes a positive. 2 negatives makes a positive. So we've got 12x squared here. Going to carry down the 0, or the 0x. Okay, and the same thing. We've got 12x squared divided by x is going to leave us with 12x. Okay, so we'll put 12x up on the top, re-multiply, we've got 12x squared, and then times 2, we've got 24x, and we're going to subtract. That becomes a 0. 0 minus 24x is minus 24x. Okay, and then we are going to bring down the minus 8. Do the same thing. This is probably the last round. Minus 24x divided by x is going to be minus 24. And re-multiply, we got minus 24x. Minus 24 times 2 is minus 48. So we're going to subtract the bottom from the top, and we're left with 0 and 8. Now the negative times the negative becomes positive, so our answer is going to be 40. So what we have here is our quotient and remainder 40. Okay. If you have any questions and you'd like to get some more help with a few more examples, let me know. Otherwise, I'll see you in the next video.